Welcome back, folks. In today's class, I'll talk about the mechanical energy. Mechanical energy. So, if I go back into the concept of energy, we did talk about two types of energy specifically: potential energy and kinetic energy. If I add these two types of energy, that's going to give me mechanical energy. It's just the sum of these two energy. So I'm going to take a analogy here. Let's say if the ball is placed on top of a cliff, and then what is the mechanical energy here? I'm going to call it as location 1. So mechanical energy is the sum of potential energy plus kinetic energy. And this height of the cliff, let's say, is 2 meter. G value, again, I'm going to take it as 10 meters per second square. Just for the sake of simplicity, it's 9.81 in real life. Now, if I try and solve this question, and the mass, again, I haven't considered the mass of the ball is 1 kg. So mechanical energy, as I said, is the sum of potential plus kinetic energy. So I'm going to write it as mgh plus half mv square. Mass is 1 plus g value is 10 multiplied by 2. This value will be 0 because the ball is not moving. It is placed on top of a cliff. So total value will be 20 joules. That's the mechanical energy. Now, when the ball is about to hit the ground, what will be the mechanical energy at that time? So mechanical energy again will be potential plus kinetic energy, and when the ball is about to hit the ground, potential energy is 0. Whole of the energy is converted into the kinetic energy. So it will be again half mv square. So depending upon whatever the velocity is, you will find out it comes out to be approximately 20 joules if there are no losses. Assuming there are no losses, in that scenario, whole of the potential energy will convert into the kinetic energy. So that was the concept of mechanical energy. Again, if I wanted to say in the midpoint, what is the mechanical energy? If there are no losses, then the mechanical energy will still stay as 20 joules. So again, the basic idea which I'm trying to convey here is that mechanical energy is the sum of potential plus kinetic energy, and if there are no losses, then the mechanical energy does not change throughout its journey in a process. So irrespective of whether the ball was placed on top of the cliff or when it is about to hit the ground, if there are no losses, then the mechanical energy will remain the same. If there are losses like the frictional losses or the resistance losses, then the mechanical energy will vary. So let's look into one of the examples on the mechanical energy. A block is moved up the frictionless inclined plane by a force parallel to the plane. At the foot of the incline, the block is moving at 1 meters per second. So this is a block on the foot. It is moving at 1 meters per second at the top of the incline, which is 0.850 meters. So this is 0.850 meters on top, and the lower end of the block is moving at 4 meters per second. So when this block reaches on top, here it is moving at 4 meters per second, and the block has a mass of 1.2 kg. The mass of the block is 1.2 kg. What is the work done on the block as it moves up the inclined plane? Now I can clearly see the work has been added on the system. So it means the mechanical energy, whatever the mechanical energy at location 1 is, that won't be same as location 2 because we are adding the work, and that's what this it's asking. What is the work added on the block to move it up the inclined plane? So I'll try and find out the mechanical energy at the location 1 first of all. So mechanical energy at location 1 will be, I'll write down the same basic formula: mechanical energy equal to potential plus kinetic. Again, this everything what we are doing is at location 1. So it is with respect to the ground, almost on the ground. So potential energy at that point is 0, and nothing is given to me. If it was given to me that this has certain amount of height with respect to the ground, I would have taken it. In this case, it's not given to me, so I'm going to assume this as 0. And kinetic energy, and that will be equal to half mv square. So mechanical energy at location 1 will be half times mass is equal to 1.2, 1.2 times v square. It is moving at 1 meters per second, so it will come out to be 0 0.6 approximately. So 0 0.6 joules, that is the mechanical energy at location 1. Now I'm going to try and find out what is the mechanical energy at location 2 is. So mechanical energy at location 2, that will be equal to potential plus kinetic again. So potential energy, because it is at a certain height now, which is 0.850, so it will be counted. So this is mgh plus half mv square. mv square, mass value is 1.2 multiplied by 9.81, and h value in this case is it is 0.850, and plus half times mass 1.2 times it is moving with 4 meters per second square, 4.0 square. Now I'm gonna go back and do the calculations, and that'll be 0.850 multiplied by 9.81 times it by 1.2, which is 10.0 approximately, and plus 1.2 multiplied by 4 times 4 divided by 2, that is 9.6. So energy on top is 19.6 joules. How much work has been added into the system? So mechanical energy at location 1 and location 2, if you subtract mechanical energy at location 2 minus mechanical energy at location 1, that will give you the work added on to the system. 19.6 on top minus 0.6, so you've added the 19 joules of work into the system. Okay, hopefully you understood this question. Now I'm gonna go to the next question. This is the next question in front of us. In this question, it says a cannonball is fired from the Earth's surface. At the peak of trajectory, it has a horizontal speed of 160 meters per second, and it is moving at 1.2 times 10 raised to power 3 meters above the ground. And this it is this many meters above the ground. Okay, and with reference to the ground, what is the mechanical energy of the cannonball? So I'm gonna draw the diagram. Cannonball is fired from the earth's surface, so it's fired like this and goes in this parabolic trajectory, and the mass of the cannonball is 5.20. On top here I wanted to find the mechanical energy, so this will be equal to sum of kinetic energy and the potential energy. I will first of all look into what is the speed here. This is 160 meters per second, and this is how many meters above the ground? This is at 1.2 times 10 raised to the power 3 meters from the ground. 1.2 times 10 raised to the power 3 meters from the ground. Okay, that's it. It's a simple question. Mechanical energy equal to potential plus kinetic, and then potential energy will be, again, we know the mass of the cannonball 5.2, 5.2 times 9.81 times height, in this case is 1.2 times 10 raised to the power 3, plus kinetic energy half mv square, which is half times mass is 5.2 multiplied by velocity, which is equal to 160. 160 square. I will do that. And now we will do 160 times 160 divided by 5.2, and then divide this by 2. That will be this much, that is 2461.54, and 5.2 multiplied by 9.81 multiplied by 1200. I'm just putting it in my calculator because I'm using my phone calculator right now. So that will be 61214.4, and then this number plus I will add 2461.54. So total energy will come across as 63,675.94 joules. Then you can convert it into scientific form. That will be 6.4 times 1234 times 10 raised to the power 4 joules. That will be the final answer for this question. Hopefully you understand now how to simplify these kind of a question. So let's look into one more problem, and this is a little more interesting compared to the previous two. And as a roller coaster trolley with the mass of 600 kg goes down from the first hill, and it drops a vertical distance of 45 meter. So it's moving like this. So this is a trolley which moves for 45 meter in the downward direction from a total height of 51 meters. So I'm gonna say this total height is 51 meter, and it moves down to a height of 45 45 meter. Okay. So we wanted to find out what is the trolley's mechanical energy relative to the top of the hill. So this is an interesting question. From here, what is the mechanical energy here? So this will be again mechanical energy at this location. We wanted to find out relative to this point. So you are losing the mechanical energy when the object is going down. So location 2, mechanical energy at location 2 is potential plus kinetic energy. Now, which potential shall I consider? Shall I consider this as 6 meter? No, because we are measuring it with respect to the top. So I will take it this distance of 45 meter, but in negative direction. So mgh plus half mv square, and this is equal to mass is 600 kg. 600 times g value is 9.81 times h value is minus 45 plus half times 600 times v square, which is equal to 30 meters per second square. 30 square. Now I will try and find out the numbers. So 45 times 9.81 times 600, which is 264870, plus this is 30 square is 900 times 600 divided by 2, which is 270,000. This is a negative number. And yeah, just I'm gonna do the calculation one more time so that I want to make sure that I am 100% correct on this one. Yeah, and then minus 270,000. So we got the 5130. This much joules of energy, mechanical energy, the object will have with respect to the ground, with respect to the top. Now, what is the trolley's mechanical energy relative to the ground? In that scenario, I will consider the height from the ground. So mechanical energy again, potential plus kinetic, and mgh plus half mv square. Mass is 600 times 9.81 times height is 6 now, plus half times mass value is 600 times velocity, uh, which is equal to 30 square. 30 square. And now this will be a positive number because you are moving up. So then this is 6 times 9.81 times 600, plus we will add the number to it. So this will be zero point 0.5 times 600 times 900. So this will come out to be 305316 joules. So that's the final answer for the second part. So hopefully you understood the concept of mechanical energy. In the next video, we will talk about the mechanical energy of an isolated system. Till then, goodbye, and I'll see you on the other side.